Okay, so what I would do here is that my task is very simple. I just want to talk about the three most important trig identities that help us in terms of like when we are coming up with reduction formulas. So it's very important that we make ourselves familiar with those four trig identities, and they're in this order. Okay, so let's say the first one is one that is that we are familiar with, like almost all of us, where sine squared of x plus cosine squared of x is equals to 1. Then the second one is I'll say it's something like sec squared of x minus uh, tan squared of x is equals to 1 as well. Okay, then the other one, it's the third one, it's cosecant squared of x, okay, minus cotangent squared of x is equals to 1. And in most cases for this one, you find that they have written it in the form uh, tangent cotangent squared of x being equals to cosecant squared of x minus 1, which is simply one and the same thing. It's like the one comes on the other side, this one comes on the other side and becomes a negative, the one becomes a positive. Okay, so these three identities are very important, and let's try to see how we are using them. Maybe even we didn't even notice that we were using them, but we used them. Okay, so for example, if I were to start with the reduction formula for integral of sec n of x dx. Remember to say we were writing this in the form sec um, sec the power n minus 2 of x, then sec squared of x dx, of sec squared x dx. Okay, so there was a point. Of course, we are not just replacing at this point. We know what sec squared is. It's simply equals to 1 plus tan squared of x there. But we are not replacing just there and then. There is a point where we had there is a point where we had something like the integral of we had something like the coefficient of n minus 2, then the integral of um, tan squared of x, then we had sec n minus 2 of x dx. So here where I had the tan replaced with what, we manipulated that identity there. Okay, so that's how we used that one. Okay, what about in terms of tan? Okay, how were we able to use that identity? So remember to say the integral of uh, tan to the power n of x dx, we have said we can rewrite it in the form tan n minus 2 of x, then tan squared of x, like that. So what we had to do is that here we just have to replace there where there's tan, we said it was sec squared of x, something like sec squared of x minus 1. So that's the identity that we use there. Okay, so what about the others? Okay, what about the others? So when it comes to the first one, okay, when it comes to the first one, which is sine squared of x, um, when it comes to sine squared of x plus cosine squared of x, when you're dealing with integral of uh, sine to the power n of x dx, there is a stage, okay, there is a stage where you reach where you have something like n minus 1, then the integral of cos squared of x, okay, then sine n minus 2 of x dx. So in this case, where there's cosine here, replace with what, with 1 minus sine squared of x, which is this identity that we use there. And the same goes for cosine. There is a point where you're going to have a sine here, okay, then of course the cosine there, so it's going to be something like sine squared of x, then cosine n minus 2 of x dx. Where there's sine squared there, you use this identity and replace in terms of what? In terms of cosine. And that's how we use that one. What about the third one? Okay, what about the third one? We use the third one in terms of cosine, I mean cotangent, as well as cosecant. Okay, so when you're coming up with let's say the reduction formula for cotangent of n to the power n of x dx, there is a point where you there is a point. In fact, we said we can rewrite this in the form integral of cotangent n minus 2 of x, then cotangent squared of x. At this point, we are replacing with what? We're replacing with cosecant squared of x minus 1, which is this identity that we used there. What about for cosecant n of x dx? How did we end up using that one? Of course, we just didn't replace there and then, but there was a point when we had something like a minus n minus 2 as the coefficient, then the integral of cotangent squared of x, then cosecant n minus 2 x dx there, where we had cotangent squared of x replaced with what? Replaced with cosecant squared of x minus 1. Okay, so these three identities are very, 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 very important. We need to keep them dear to ourselves, because they are the ones that makes you coming up with reduction formulas very, very simple. So we need to keep them in mind, and they will really help us in one way or the other. Thank you very much for watching.